You actually have to do this out. I know it's kind of annoying. End up with 1 plus h cubed minus 5 times 1 plus h plus 1 minus, what's f of 1? Negative 4, negative 3? Is that correct?
It's 3.
It's
Yeah,
3?
it comes out, yeah, it's negative 3, but then you add.
Yeah. Over this, correct?
Yeah.
So you end up with 1 plus... What do you have to do at this point, unfortunately?
You have to do that.
Yeah, 1 plus 2h plus h squared times 1 plus h minus 5h plus 1 plus... Is that correct?
Yeah.
Yeah. So then you end up with 1 plus 2h plus h squared plus h plus 2h squared plus h cubed minus 5 minus 5h plus 4. I'm going to combine those last two. A few things cancel off the bat, right? We get that 1 with 4 and then minus 5, right? Is that all gone?
Yep.
And then you're dividing by h, correct? I'm just going to go a little bit quicker here. So you end up with 2 plus h plus 1 plus 2h plus h squared minus 5. And it's the limit as h goes to 0. So a lot of these just go away. 0, 0, 0. So what are you left with? 3 minus 5 is negative 2. So you know that f prime of 1 is what? Negative 2. And you're going through the point 1 comma f of 1.
Okay.
So it says, and use it to find an equation of the tangent line at the point. Oh, look, they even give you the output. What is f of 1? They even tell you it. What is it? I don't think it's 3. It's negative 3, right? So the point is 1, negative 3. You have a point and you have a slope. So y plus 3 equals negative 2 times x minus 1. There it is.
When you put that in your calculator, it's not the tangent line.
You don't think so? Okay, well, check it out. So yeah, it does work. There it is. There's the function and there's the tangent line. They just want you to actually see it. Yeah, exactly. It tells us. It tells us right there. It's 0, right? So what do we have? We have the limit as h goes to 0 of f of h minus what? 0 all over h. So we end up with the limit as h goes to 0 of f of h all over h. Now, we have, as h goes to 0, what is the function? The function is x squared sine 1 over x. So we end up with the limit as h goes to 0 of h squared sine what? All over h, right? So what does that equal? The limit as h goes to 0 of h sine of 1 over h. And we already did the work above by the squeeze theorem. It doesn't matter if it's h squared or h. The same thing happens by squeeze. What do you know is true? This is equal to what? 0. So therefore, for this function, f prime of 0 is equal to 0. So does it exist?
Yes.
Yes, because we found it. So sorry about that. It's a lot. We were doing the right thing. We were just defaulting back to this function when specifically, what does it tell us? The function at 0 is going to be, it's filling in the dot for us. Like, we knew it was undefined, and it told us. It's basically like the stove is hot, don't touch it. And we're like, what? What? At that point. D&E. If this is x equals a, f prime of a is said to not exist, because the left-hand derivative and the right-hand derivative are different. They're not the same. So, but is this continuous? It is continuous. What's the simplest way you can explain that that has to be continuous? I didn't lift my pencil up off the board or off the screen, right? I was able to draw it without lifting it up. So this is important. Differentiability implies continuity, but continuity does not imply differentiability. It might be useful to prove it's continuous in your quest to prove differentiability.